All right, my Algebra 2 students, if you are watching this, it's because you came for some explanation on the answer key for the Desmos activity that was practicing operations of functions. Typical Rosicky fashion, I recorded this whole video and realized that the microphone wasn't on, so I have to do it again. Love that for me. But here we go. So again, answer key, operations of functions, the Desmos activity. If you're watching this, it's because you want an explanation. So here it is. Feel free to, you don't have to watch the whole thing. Fast forward to the one that you need. If you are just confused about everything, then watch the whole thing. I don't care. Up to you. That's the joy of YouTube. You can speed me up. You could slow it down. Fast forward, rewind, pause, all that good stuff. All right. So numero uno says, what is g of 10 plus f of negative 2? First thing I'm going to do, I color-coded all of my functions up at the top. G of x is my orange one, so I'm going to find g of 10. And g of 10 means I'm going to put 10 in for the x, and I'm going to simplify. So negative 29. And then I'm going to find f of negative 2, which is my green function. And I'm going to put negative 2 into my function using parentheses every time I substitute. Negative 2 squared in parentheses is positive 4. 4 minus 4 is 0. So g of 10 plus f of negative 2 is equal to negative 29, because that was g of 10, plus 0, because that was f of 2. If I simplify that down, I get negative 29. So g of 10 plus f of negative 2, negative 29. Let's look at, I shouldn't have used that blue because that blue is for function. Why won't this let me circle it? There we go. We'll do, I don't know. I'm running out of colors. Light blue. Sorry, I'm trying to keep my color coordination intact here. So I don't want to use a color that I've already assigned to a function because I don't want to confuse you. So I'm going to change to light blue for that. Okay, now I'm going to look at number 2. So k of negative 1, which is my pink function, k of negative 1 is going to be 2 times negative 1 plus 9. Simplify. That's negative 2 plus 9. That is 7. And then h of 4, I'm going to sub that into that blue function. That's going to be 12 over 4. That's 3. So k of negative 1 over h of 4 is equal to 7 over 3. And obviously, if you're typing this in Desmos, please use the nice equation editor. So that's 1 and 2. I'm just evaluating some functions and adding their values and dividing their values. So I'm doing operations, but I'm doing them while evaluating. So I'm taking a couple of scales and putting them into one. Here is sort of a different type of problem. Notice here, this is saying find x when f of x equals 0. This is not the same. So let me, g of x was orange and f of x was green. I'm going to keep that consistent. So notice that this is not the same as this. Those two are very different. Okay, we've compared and contrasted things like that in class. Those two are not the same. Right, f of x equals 0 means set the function equal to 0. So I'm going to do x squared minus 4 equals 0, or you could also do 0 equals x squared minus 4. Doesn't matter. I'm then going to add 4. To undo a squared, you take the square root of both sides. Don't forget, when I take the square root of both sides, I get two answers, one positive, one negative. And the reason that happens is because our graph is a quadratic, right? Our equation is a quadratic, and this quadratic, x squared minus 4, is a regular quadratic shifted down 4 units. We should know that from our transformations, right? So shifted down 4. If the point exists on one side of the quadratic, it must exist on the other, right? And actually, in this case, the y value was 0, so it would be here and here. So there are two places where the y value is 0. So that's why there are typically 2 when I take the square root of both sides. Here it's talking about g of x. So again, I'm going to set the function equal to 16 this time, and I'm going to set the g function. So it's negative 3x plus 1 equals 16. And solve. This is linear, so nothing too fancy. X equals negative 5. When my answer is x values or says find the value of something, you should put that value equals, right? So here, notice I have x equals for both my answers. Before I just put the number, but x equals is really good here because it says find x. Here I'm going to do my operations of my functions without values. So I'm going to subtract, add, multiply, whatever it asks me to do. Again, I'm going to highlight my functions in different colors so that I am consistent with showing my work. I changed the f of x function here to make a little more sense for what we need. So that's why it's different from the earlier problems. But g, f, and k are all still the same. So problem number 5 asks me to subtract, and when I subtract my functions, I need to put parentheses around my second function. So I'm going to subtract, and then I'm going to put parentheses around my k of x, which is 2x plus 9. And the reason I do that is because I want to subtract the entire function, each term of the function, each piece of the function. So I'm going to distribute that negative. And then I can combine my like terms, so negative 3x and negative 2x is negative 5x, and 1 and negative 9 is negative 8. So that's the new function that I've created by subtracting two existing functions. All right, so when I multiply functions, I want to make sure I put both functions in parentheses. So here f of x is x squared minus 4, and g of x is negative 3x plus 1. And then when I multiply, you've definitely heard me probably say FOIL before, but really all you're doing is double distributing. So you take your first term and you multiply it by each term in the second set of parentheses. So I'm going to do x squared times negative 3x to get me negative 3x to the third. And then I'm going to do x squared times 1, which is boring, it's just x squared. And then I'm also going to take my -4 and I'm going to multiply it into both terms of the second set of parentheses. So it's going to be -4 times -3x, which is positive 12x, and -4 times 1, which is just -4, so -4. And that's the final answer there. There's nothing super fancy about that. It's already in the right order from highest exponent to lowest. So that's my new function based on multiplying two old ones. So I've multiplied a quadratic and a linear, and I've gotten what's called a cubic because it is degree 3, has the highest exponent of 3. Addition's simple. I can just add the functions, nothing fancy. So f of x, x squared minus 4, plus whatever my h of x was. I don't need to use parentheses when I add, so plus 2x plus 9. Combine your like terms. So x squared doesn't have a like term. -4 does. It's -4 and positive 9. So x squared plus 2x plus 5. Again, nothing too special. It's in order from highest to lowest. I've created a new function by adding 2. I've got another multiply here, so this time it's g of x times k of x. So I'm going to do -3x plus 1 times k of x, which is 2x plus 9. And then comes my double distribute again. So -3x times the first term here and times the second term here. So it's going to be -3x times 2x, which is -6x squared. And then -3x times 9 is -27x. And then I'm going to take the 1 and I'm going to multiply it to both terms here. Again, multiplying by 1, pretty boring. This is just plus 2x plus 9. Again, actually this time I do have like terms. My two middle terms are like terms. So this becomes -6x squared minus 25x plus 9. And last but not least, it wants me to divide h of x and g of x. For the purpose of this unit, division is super simple. We'll actually learn how to divide functions later on in the year, but right now, dividing functions just means write one on top of the other. So h of x was 2x squared, and g of x is -3x plus 1. There is nothing that can be done there. I can't cancel the x's. I can't divide by 2. Like nothing gets divided. It just is that. I would write it in the box, but it'll look kind of funny because I don't have the right amount of space. So that's working with functions without evaluating, so just taking functions and turning them into new ones via operations. I can do operations with functions, with tables, with graphs. You'll see graphs in a second, but here let's focus on this table. So my function is named f of x. That is the name of it. So 3 times f of 0 means do 3 times whatever the value of f of 0 is. So I'm going to go to 0 on my table. What's the output? It's -1. So this is 3 times -1. And then it wants me to do plus 4 times f of 2. So f of 2 is 5. So this is going to be plus 4 times 5. Follow PEMDAS, multiply. So -3 plus 20 comes out to be 17. Right, so that's when I'm evaluating using values from a table. Here it's asking what's the x value when the function equals -6. So this is the output is -6. So I'm going to look at my outputs, which is my f of x column. Find negative 6. What's the x value? X is negative 2. Sometimes there might be multiple, so just check your table for that, but in this case there's only one. Notice the answer is x equals. Notation's important. So these ones can be a little overwhelming, but take it step by step. So again, I'm going to highlight my functions. F was green earlier. It's a different function, but I'll use the same colors. So F is green, G is orange. Don't actually like these colors, but whatever. So start here. It's asking me f of 4, right? So there's a whole equation, but f of 4 is involved, so I'm going to find f of 4, and I'm going to do it up here to save space. 2 times 4 is 8. 8 minus 7 is 1. So f of 4 we just found is 1. And then it also asks me about g of 3. It says 2 times g of 3, but I'm going to find g of 3 first. G of 3 is negative 3. So this has become 2 times negative 3. So my function now, or my equation that I'm trying to solve is 1, because that was f of 4, plus x plus 6 equals negative 6. Because 2 times negative 3 is negative 6. And now this is a simple linear equation that I can solve. So I'm going to combine like terms. 1 and 6 become 7. Subtract 7 from each side. X is negative 13. It can be intimidating. I understand that, but really it's all about substituting and solving. Substituting and solving. So find the value of a, or for what value of a is a equal to f of a? Well, first of all, what the heck is f of a? Well, if f of x is 2x minus 7, then f of a must be 2a minus 7. So it just really wants to know, when is a equal to 2a minus 7? And I can just solve that for a. So I'm going to subtract 2a from both sides. That's negative a equals negative 7. So a must be 7. Again, not difficult to solve it, but if you don't understand how to substitute properly or how to set up the problem, then you won't be able to solve it. So I do understand that the setup is difficult, but at the end of the day, you guys can do it. You are totally, totally capable of doing this. You have the skill. You're going to do great. All right, few more here. So here we're going to talk about graphs versus tables. And how do I know which to look at? You pay attention to the letter that this is referring to. So g of x, so anything that is g, means look at the graph because the graph is labeled g of x. F of x, so anything that's asking you about f, is going to refer to the table. So f of 3, this means what's the output if x equals 3 from the table? So I'm going to find x equals 3. What's the output? 9. So f of 3 is 9. G of 5, similar process, right? So what's the output from the graph, or what's the y value, because output and y value are the same. So I'm going to go over to my graph. I'm going to find 5, find the point. Here it is. This is the point 5, 1. So f of 5 is 1, because that was the output. That's the y value of the point. Oops, g of 5, not f of 5. One day I'll make a video without mistakes. One day. Today is not that day. So, f of negative 2, go to negative 2 in the table. What's the output? 8. G of 0. So go to the graph. G of 0 means x equals 0. Follow it up or down depending. This is the point 0, 3. So G of 0 is 3. That's the output at 0. And last but not least, f of 0. Go to my table, find the x value of 0. What's the output? It is 4. So f of 0 is 4. So that's evaluating. So that's given the input, find the output, right? That's what each of these problems is doing. Given input, find output. And here I'm going to do operations, similar to before. So f of 2, again, go to my table, right? My table is f. So f of 2 is 8. So f of 2 was 8. G of 4, so I'm going to go to the g function, go over to 4. What's the y value? This is the 0.40. So g of 4 is 0. And you just want to add these. So 8 plus 0 is 8. Here it's asking 3 times f of 2. I know f of 2 from the previous one was 8. So 3 times 8 is 24. And then g of 4, I also knew was 0. Wow, Rosaki did not get creative with this problem. So it's going to be minus 0. So 24 minus 0 is just 24. Simple enough. How many more? Last one. This time, they're giving you the output and asking for the input. And I'm going to put inputs in parentheses because there could be multiple. So for what values of x is f of x equal to 8? So basically, look at the f of x column. Find 8. What's the input? Surprisingly enough, right on this first one, here's 8. I get x equals negative 2. However, I also see an 8 down here, so x is also 2. It is both x equals negative 2 and x equals 2. There are 2 of them, multiple. You need to state them both. Here it says what values of a is f of a equal to 4. It does not matter. I'm still looking at the table. This is the output, so I'm going to go to 4. What is the input? 0. And I'm just using a because that's what it told me to use. And last but not least, we've got g of x is negative 2. That's y equals negative 2. So I'm going to go up to the y value, or down to the y value of 2. Draw a line straight across because sometimes it could intersect more than once. Here it only intersects at this one point. This is the point negative 3 comma negative 2. So it's x equals negative 3. But I want to show you. It could have been here at 1. Right at 1, there's a few. There's this point, and there's this point. I don't know what those x values are because there's no actual points on there, so that's why I didn't ask about that. But you've got to look at the whole graph, not just one piece of it. And that's the answer key. That's operations with functions. If you have questions that this video does not explain, please email me. I'm happy to answer them. Thanks, guys.